if you really want to think about gravitational potential energy as the amount of work you need to do to lift an object above for a certain height, then you can actually derive the formula using the following method. First, I have to say work is change in energy. That's what energy really is. And here we're looking at a change in potential energy. Right? Change in potential energy, which by definition is the final potential energy minus initial potential energy. Just like all the changes. So you can think of an object, start from this height, or this distance, which you have potential energy you don't know, and you lift it, and you also have a potential energy you don't quite know, but you can at least calculate the change between them. However, if you pick a reference height, like relative to the ground, right? The object's on the ground. If we say this on the ground has zero potential energy, that's our decision. Okay, we're going to choose the ground as reference. Okay, so let's say on the ground, EPGI equal to 0 joules. Then you will notice the final potential energy is equal to the change. If we let the initial be 0, that is. So we let this be 0, we make a decision to think on the ground, it's reasonable. I think it's reasonable to define 0 to be on the ground. So if the initial is on the ground, because on the ground, and you'll find the final potential energy is equal to the change. So we can just define the final potential energy to be the change in potential energy, because they're equal if we define 0 to be on the ground. However, what is that? Well, wait, that is just work, right? Work, which is force times the displacement at height given. So let's take a look. Let's say this object has mass of m. It won't change, of course, when you lift it up. Okay, and the height it lifted from, the distance it lifted is h. The distance it lifted is h. Then the acceleration, you need to carry it through, which is how much force you need to apply. Force is going to equal to gravity. And distance, you have to move that object, at least say small minimum amount of work. You need to go from one place to the other. It's just going to be h. That's all you need to do. Okay, that's all you need to do. So that is equal to, remember, the potential energy at the top, EPGF. Oh, I missed the F here. Gravity, of course, we already know, is mg, the magnitude, times h. Direction are the same. However, of course, there's no reason we can call it final gravitational potential energy because initial is 0. We can just call it the potential energy at height h. So if we generalize it, you can easily see that in general, gravitational potential energy is equal to mgh, because we can change h to any number. H is just a variable, right? We can change h to any number. It doesn't have to be EPGF here. So we can easily generalize it for any h. So we can say gravitational potential energy at any given height is mgh. The key thing here, however, that you may notice that this h is relative height. Okay, relative height. Now, the standard, commonly we would say on the ground, gravitational potential is 0, but there's absolutely no reason to. On a great scale, stellarly, we usually say gravitational potential energy is 0 in the center of the planet. If we do that, everything would change. Okay, everything would change. So gravitational energy only makes sense if you pick a reference height. For the purpose of science 10, reference is usually the ground, but you can change that. Okay, you can change that. Calculation will all be different. So you may want to stick with ground because it makes calculation easier. It's common. However, EPG only makes sense with the reference height. What's the reference height? It's basically when EPG equal to 0 joules, or basically, in a sense, when the height is 0. Whatever 0 is. EPG would not make sense without a reference height. So this is a detailed version of where the potential energy formula come from, and some intricate details working with this formula. In Science 10, we usually don't have to worry about this, but this thing will become important when we're looking at physics beyond just Science 10 level. All right, thank you for watching. Hope you have a great day.